The flight management part of the FMGC performs four main functions: navigation based on accurate position, flight planning, performance prediction and optimization, and management of the displays. Accurate position computation is one of the essential functions of the FM part of the FMGC. Each FMGC computes its own aircraft position, FM position, from a mixed IRS position, and a computed radio position, or a GPS position. The system then selects the most accurate position, considering the estimated accuracy and the integrity of each positioning equipment. The FMGC computes a mixed IRS position from the three IRS. If one IRS fails, each FMGC uses only one IRS, onside IRS or IRS 3.
Each IRS computes a hybrid position that is a mix IRS GPS position, called GPIRS. Only one of the three GPIRS positions is selected by the system, according to its figure of merit and priority logic. If the GPIRS data does not comply with an integrity criteria, the GPS mode is rejected and the radio position updating is used. GPS primary lost is displayed on ND and MCDU scratch pad.
Each FMGC uses on-side nav aids to compute its own radio position. The nav aids, which are automatically auto-tuned, can be DME, DME, or VOR, DME, or DME, ILS, lock DME, ILS approach selected, or VOR, ILS, lock DME, ILS approach selected, or DME, ADF, NDB approach selected, or VOR, ADF, NDB approach selected. Each FMGC computes a vector from its mix IRS position to the radio or GPS position. This vector is called bias. The bias is updated continuously if radio or GPS position is available.
If the radio or GPS position is lost, the bias is memorized and added to the mix IRS position to compute the FM position. Note, at takeoff, the FM position is updated to the runway threshold position memorized in the database.
Depending on the navigation mode used by the system, IRS, GPS, IRS, DME, DME, IRS, VOR, DME, or IRS only, the FMGC computes an estimated position error, EPE. The EPE is then compared to the required navigation performance, RNP, defined by the airworthiness authorities, as the nominal error tolerated within a flying area, TMA, or along a given flight plan leg.
If the EPE is lower than RNP, accuracy is high. If the EPE is higher than RNP, accuracy is low. When the accuracy switches from high to low, a message, Nav Occur Downgrade, is displayed on ND and on MCDU scratch pad. When the GPS function is lost, the crew must check the position accuracy using raw data information if available.
The position accuracy cross-check using raw data information has to be done periodically during the flight, unless GPS is primary, systematically when GPS primary lost message comes up, and systematically when nav occur downgrade message comes up.
Keep in mind that high-low messages are computed on estimated data. Therefore, even if low is displayed, the accuracy check may be positive.
For flight planning, the pilot inserts the following data into the FMGS via the MCDU. The lateral part of the flight plan, the vertical part of the flight plan, speed, time, altitude constraints or step climb. In fact, 2 flight plans can be inserted in the FM. A primary one, used for the legs to be flown, and a secondary one, used to prepare an alternative departure, or arrival, or a diversion, which can be activated by the pilot whenever required.
The Flight Management System, or FM, uses 2 databases to perform its computations: a navigation database and a performance database. The Navigation Database, or NAV database, contains all the necessary information for the lateral flight plan, such as routes, airways, VORs, non-directional beacons, waypoints, and airports. The navigation database is updated every 28 days, and its currency and validity is checked on this page during the pre-flight. Notice there is an active database and a secondary or second database. The secondary second database is either the previous or the next database. Databases are loaded 2 at a time, so that if the first one expires away from a maintenance base, the pilot can activate the second one before departure the next day. Warning: never activate the second database in flight, as all current active data would be lost. The Performance Database, or PERF database, contains the aircraft performance model and is used to optimize the flight plan and to obtain predictions such as ETAs, EFOB, etc. The change code, CHG code, allows the engineering team to modify the idle and performance factors in order to take engine aging into account.
The lateral flight plan includes departure, en route, arrival, and alternate. These elements are defined by waypoints and legs. The FMGC strings automatically the legs in sequence. When flying in nav mode, navigation managed by the FMGC, the aircraft is guided on a leg, called active leg, defined by a from and a to Y point. The to Y point is depicted in white on the MCDU, and on the MD as well, in the top right-hand corner.
During pre-flight, the first thing that we do is confirm the correct information on the status page. We are then ready to begin programming the route of flight. This is called initializing the flight plan. This initialization of the flight plan is done through the init page A. We will call it for you.
The pilot enters the flight plan in either three ways: by inserting an origin-destination pair and then manually selecting a departure, waypoints, airways and an arrival, or by inserting a company route name stored in the database, or by sending a request for an active flight plan initialization CFANS course. The flight plan, once inserted, can be modified by two types of revisions: lateral revisions, which have an immediate effect on the active flight plan, or lateral revisions that led to a temporary flight plan. These revisions are selectable from the left keys on the MCDU.
The direct to function is an immediate effect lateral revision which allows the aircraft to fly from the present position directly to a waypoint, with A-beam points displayed along the track if A-beam PTS is selected, or to intercept an inbound or outbound radial to from this waypoint. If the waypoint is by the crew, place bearing, place bearing, place bearing. Deleting a waypoint in the flight plan will create a flight plan discontinuity in the active flight plan. Adding a waypoint in the flight plan will create a flight plan discontinuity. Using a lateral revision at origin, the pilot can insert or modify the takeoff runway, the SID, and the en route transition through the departure revision. The en route transitions, trans, are the various possible trajectories defined between the last waypoint of the SID and the first en route waypoint. There are 3 transitions available in this example. A lateral revision at destination, line select key 6 left, gives access to the arrival data. The runway and the type of the approach can be chosen. As well as the star, the via, and the en route transition. Approach vias are the various possible trajectories defined between the last point of the star and the first point of the approach. The revision at the from waypoint, PPOS, allows the pilot to define a lateral offset to the left or the right of the active flight plan. The offset value inserted is in nautical miles. Once the offset has been inserted, the initial flight plan appears as a dotted line. A lateral revision at a waypoint allows the pilot to insert into the active flight plan up to 5 segments of airways starting at the revised waypoint. The Airways page is accessed by the Line Select key 5 right on the waypoint Lateral Revision page. The revision is done for each segment by first inserting its airway identification, and then by inserting its ending point. After the insertion in the flight plan is completed, some cleaning may be required.
A holding pattern can be inserted from a revised waypoint using a database hold at. The parameters of the holding pattern are stored in the navigation database, or using a computed hold at. The parameters of the holding pattern are defaulted to predetermined values, which can be modified. Once a holding pattern is inserted in the flight plan, it is initially not taken into account by the FMGC for prediction computation, as the system does not know if the pattern will be flown. Once entering the holding pattern, the system considers that only one pattern will be flown.
Prior to entering the holding pattern, if managed speed is active and navigation mode engaged, the target speed will automatically be set to the computed holding speed. Or, if the speed is selected, a message, Set Hold Speed, will be displayed on the MCDU and PFD.
The holding speed is the lowest of maximum endurance speed, or ICAO, limit holding speed, or speed constraint, if any. The FMGC predicts the latest estimated time at which the aircraft must exit a holding pattern and the estimated amount of fuel, so as to fly to destination according to fuel policy. Extra fuel equals 0.
This revision allows the pilot to select an alternate airport. Several alternate airports may be stored in the database. The alternate page displays the track, distance, and extra fuel corresponding to the different alternate airports. This assists the pilot in choosing the alternate airport according to weather conditions or fuel considerations. A lateral revision allows the pilot to initiate a diversion to the alternate by selecting the alternate flight plan from any revised waypoint belonging to the active flight plan. A flight plan discontinuity will be displayed between the revised waypoint and the first waypoint of the alternate flight plan.
The vertical flight plan is defined by strategic data affecting the overall flight plan, tactical data affecting a given phase of flight, and weather data. This data is either inserted by the crew or stored in the performance database.
The strategic data is cruise flight level and temperature, tropopause, cost index performance factor, trip wind, zero fuel weight CG, block fuel. The flight plan is divided into flight phases: pre-flight, takeoff, climb, cruise, descent, approach, go-around, done. Each phase is characterized by its target speed profile: V2 plus 10, econ climb, cruise, descent speed, Mach, V approach. The speed profile is also called managed speed profile. The vertical flight plan includes vertical constraints assigned at waypoints, altitude and/or speed, which are stored in the database and entered manually by the crew. Another constraint, the requested time of arrival, or RTA, at the revised waypoint, may be entered by the crew. Also part of the vertical flight plan are constant Mach segments, defined by a desired Mach value and its associated starting point.
The vertical flight plan also includes weather data inserted by the crew, temperature at flight level and destination, and winds, climb, cruise, descent, approach. The FMGC optimizes the cost of operation, computing econ speed Mach for each phase of flight. These speeds Mach are computed as a function of gross weight GW, cost index CI, cruise flight level FL, winds temperature models and actual ones, and performance data.
Cost index CI is the ratio of flight time cost to fuel cost. It is used to compute the best econ speed, or Mach. CI equals 0 corresponds to minimum fuel consumption, or maxi range. CI equals 999 corresponds to minimum time.
Additionally, the optimization function provides the following data: maneuvering speed for takeoff, approach, and go-around, O, S, F, approach speed, and VLS and landing configuration, and optimum flight level, and recommended max altitude. The optimum flight level is the one at which the aircraft incurs the lowest cost for given flight plan, gross weight, and CI. Note, these terms will be discussed in more details in the performance course.
Takeoff speeds V1, VR, V2, as well as the flex takeoff temperature or DRT takeoff level, are manually inserted by the crew in the MCDU.
The FMGC computes predictions for the primary and secondary flight plan whenever the lateral and vertical flight plan are completed, and when all strategic and tactical data is inserted. These predictions comprise top of climb, TC, and top of descent, TD, fuel, speed change, etc. The PFD provides the guidance targets on each dedicated scale. Speed target, vertical deviation, altitude target, and heading or track target.